Hey everybody, Adam Savage in my cave with a 3D printed, quick and dirty 1 hour build. Not even an hour maybe. But it's a really cool build and it highlights a sort of hidden lovely thing about 3D printing that I'm really grooving on. You are watching me on a screen. A mechanical process. It's digital. But from a physics standpoint, even digital is a process of atoms and things moving around. You're watching me on a screen, and that screen is a grid of pixels. Those pixels are addressed, and every frame of the camera's capture of what I'm saying to you is being processed and delivered to you. That seems obvious, right? We understand how display works, but for most of human history, actively displaying information was impossible. How many different noises can we cough up here in the cave? I'm not going to worry about the compressor. I'm just going to let it spin its wheels. Edit? No, I got to turn it up. Hold on. I have to replumb my air. For most of human history, the display of information, which is writing, has been a robust process that's been around for thousands of years. But the act of updating of information is a recent human invention. And before we had screens, amazing. That was Damien, my UPS guy. Not my UPS guy. This. Okay. Before we were updating display of data, until these screens, the best way to update data on a display was mechanically. And I have a long history of loving mechanical displays. One of the most beautiful rooms in the world is the main hall of Grand Central Station in New York City. I think the main ceiling is 6 or 7 stories high. It's one of the most beautiful rooms in America. And when I lived in New York, that was where I would meet you by the clock on the north side at 1 p.m. or something like that. I even learned how to pick the locks on the door. The windows on either side of Grand Central, these giant windows facing east and west, actually have walkways in them. And back in the 80s, I figured out how to pick the lock with a butter knife and spent a lot of weekends urban spelunking through the rafters of Grand Central Station. But one of the most evocative and memorable parts of the old station were the train boards, which were flap wheel data displays. And I grew up on the Croton-Harmon line, Irvington, Ardsley, Dobbsbury, Hastings, Greystone, Glenwood, Yonkers, Ludlow, Riverdale, Spuyten Duyvil. Like, this is just in my blood, the train from upstate, Westchester County, from Westchester into New York City. And when you were looking to see if your train was where your train was, what track you were going to look on, there was this big board. It's now all digital, but it used to be mechanical. And there was this point at which, like, every 5 minutes, the entire sign would change over. And it was just this beautiful cascade. And like, it's one of my earlier memories. I used to go to the city with my dad, and it was such a special occasion. And I feel like there's an aspect of really loving that sign for a young me that was the harbinger of the engineer I would end up becoming. Nothing but extra sounds, isn't it? Silence. Because a flap wheel sign, like the old radio alarm clocks and stuff like that, or updating perpetual calendars, are a beautiful solution to a problem of data display. Absolutely magnificent. And it's not the only one. And so today we're going to build a 7-segment mechanical display designed by actually I'll tell you who it's designed by. Flower 3D, and we'll include a link to the 3D files and also to their assembly tutorial. I will be watching that tutorial to put this together. And this is a mechanical 7-segment display, so it counts from 1 to 10 or 10 to 1, depending on how you arrange it. And I built this off camera to get to know it, and it's a lovely piece of construction. It's a refined bit of printing, and I think you will enjoy printing this and building it. Ergo, I have printed it and I'm going to build it now. Now, every time I print something, I print a lot of extra. Okay. Every time I print stuff, I print lots and lots of extra pieces. And it's really good practice too. The thing about your printer is it wants to be used. It wants to be useful. It performs the best when you keep it regularly operating. So it is, what I have found is when I neglect my 3D printers and I don't print for a month, when I come back, I have to fix one of them. And fix just means like some bit of filament broke off inside, I got to clean it out. Like, it's not that hard to maintain, but I notice when I just keep them going, they operate much more reliably. And so I use that necessity of keeping machines running, just like I'll just run a print twice. And I'll go over to the machine to pick up the print and I'll just say, print again, that's great. I intended to print these in black, but I ran out of black filament and I've got this medium gray, which I like. And I think these are all the pieces that build it. And I think that we're gonna get started. So let's see here. There it is, operating. There's one aspect of this build you're not going to witness me do, which is the soul of this build is a set of cams, of stacked cams, that ingeniously allow movement of the segments in and out, depending on where you are within the counting sequence. So these two wheels allow for 10 different states of the segments as they move in and out of their segment matrix. I put this together off camera. I did not print a second set of these, and they're delicate, and I would rather not unassemble them, deassemble them, disassemble. All right, so here are all the parts and the pieces and yeah. This is the center segment display. So it goes like that to that, 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 to that. So center segment comes in and yeah, and it's a little bit of a kick. There it goes. And now there's a rubber band. Rubber band. Cam stacks. Okay, so that one goes, yep, there. And this one oh, yeah, turn it to the, okay. And this one. Yeah, okay, it moves it. Good. All right, so this is pointing at each other. Great. 2 arrows in the middle are pointing at each other. That's awesome. Okay, next up is the segments. So the segments are, they come in like this. And, yep. All right, the 7 segments are in, and it looks like there's 1, 2, 3, 4, 5, 6 segments are in, and it looks like they're correctly placed. All right, yes, I see that they're riding correctly where they need to be. All right, no more ads. One thing about the segments is when you're putting this together, that wants to be the smoothest slide. I found that the different end segments sometimes had different amount of slidability. If there's any stiction on any of these, it's not going to function properly. That's why I printed a couple of versions of each. A little light, a very, very little amount of light machine oil also works great. And I'm going to add that at the very end. All right, rubber band. Here comes the bigger rubber band moment. All right, here we go. We're going to... All right, so the band comes up, and up, and up. Gotta go. Key thing here is to make sure that here that the rubber band is on the inside. But again, we're going to include a link to the assembly video here, and it's really, really straightforward. Okay, so we're getting movement across the whole thing. I'm very pleased. We're going to bring in this part. Ooh, 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 ooh. It's looking good. It's looking interesting. Gears. Okay, so the 2 gears are, there's a 3.0 with an arrow 1 and 3.0 with an arrow 2. Here's how these are going to go. And depending on how you lay these out, makes it count up or down. I'm going to count up. And so that is 1.0 on top, facing down, and 2.0 at the bottom, facing up, and the arrows meet each other. Oh, right. And there are 2 arrows on the gears that actually meet. No ads. No ads. Mid plate, that's this guy. Oh no, that's this guy. This is where some of the spring work happens. All right. Make sure cutouts at the top align. They do! Excellent. And so now we have these guys, which are A and B. So got these. 3.0. B. All right. So if that goes there like that, nope, it's that one. Yes, it's that one, right? Yes, the arrows are pointing into each other. Oh, no good. NG. This print has some muckery about it. We're going to use that print instead. And it's the same orientation. Yeah, same piece. Okay, so there's that. Great. And that means that this is also facing down. Like that. Great. Great. And we're going to have the other one go at about 8 o'clock. Oh. Yes. The next step in this journey is the addition of two 4mm by 50mm springs. I had them in the cave here, and I've installed them here. Again, you don't, yeah. All right, so here we go. We're putting the springs in, they're in. Oh, now comes the push rod. This is how everything operates, and it connects up to, all right, so yes. And we can test operation. We can now do a test of operation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dude, that is really awesome. Okay, that's working beautifully without any oil at all. I did wash my parts so that any glue that was on the build plate is no longer there. And so now we bring in the back plate. That's this guy. And that goes in. Saw. And then these little screws. He has printed these with threads and both inner and outer, which is amazing. It assembles in just a very positive way. And then, are we done? We are almost done. Yeah, we are. Okay, here's how it goes. 1, 2. I paused because to me this said 5. 2, 3, 4, 5, 6, 7, 8, 8, 9, 10. Dude. How awesome is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is not the only 7-segment display that is out there on the 3D printing land. There are multiple mechanical segmented displays, and the flap wheel I was talking about before, there's a bunch of those too. We don't necessarily need displays like this because LED, LCD, OLED have all gotten so inexpensive that, and we have enough processing cycles to manage these giant Excel spreadsheets, which are the video signal. That is not my rhetorical flourish. That is Matt Parker, Stand Up Maths. He actually did a whole video where he explained that a photo was effectively a database file, like an Excel file, and he built a photograph with Excel, filling every cell. Yeah, no, it's totally amazing. But it would be a shame if we lost this knowledge. The engineering in this is really lovely and elegant. And I love also that builders are building iteratively so we can see version 1.0, version 2.0, version 3.0. That feels like a relationship. And look, in the right way of sort of fomenting, let's build this together. And when I first started looking out at Printables and Thingiverse and Cults 3D and all those other places where you can get files to print, I was really impressed by how bad most of the drawings out there are. And I don't blame the artists because the CAD/CAM pipeline is still rough to translate stuff from here onto here into the real world. But there are some high spots out there. And this right here, again, will include a link to their printables files and their YouTube videos for executing this build. Is very satisfying, feels really good. I printed all this at 100% infill. It's all basically shell, and so even just with like 5 layers, it probably was going to be 100% infill, but I also like the feel and the weight of the plastic when I do that. So I often let my builds take a little longer than normal just in order to get that. Oh, here we go. That's amazing how fast that actually works. Mwah! Thank you guys for joining me for this very quick and dirty one-day build. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See you guys next time. Cheers.
Thank you guys so much for watching that video. I would be remiss if I didn't tell you we have some excellent merch. We have a 5-pack of demerit badges for sale right now at tested/store.com. We've got the I hung it off of level demerit badge, the I built the chair backwards demerit badge, the I hit my thumb with a hammer demerit badge. We've got the stapler in my finger demerit badge, and my favorite, I stuck the duct tape to itself demerit badge. Get yours now, tested/store.store. Tested-store. Tested. It's right here. There. Just click there.